What evidence is there to justify introducing yet another file design?
Well, we've conducted over 2,000 computer-controlled evaluations, testing different file configurations. I designed a computerized clinical simulator to enable us to precisely reproduce the various clinical motions that simultaneously measure the torque, the pressure, and the time while using different instruments. This gives us a profile of the instrument's efficiency and its propensity for failure. You know, when eliminating operator variability, computer programming enables us to control the instrumentation parameters for the depth, the speed, and the force of file insertion and withdrawal, as well as the speed of rotation. All measurements can then be plotted in real time to illustrate when and how stresses occur. We're no longer encumbered by measuring the specific flexibility of a file under a specific condition. The simulator can be used to measure dynamic flexibility, recording stresses as a rotating file advances through different canal curvatures. Rather than having to rely on subjective impressions that lack the benefit of controls, with the log data, the specific characteristics of a particular file becomes apparent. Potential design improvements become more evident, and we find that even minute changes in design can make a very big difference. An examination of the results puts the manufacturer's claims on trial. And contrary to the fact that virtually every file is marketed with its particular technique, the results illustrate that the more ideal the file design is, the more ideal it is for any technique. That's not to say that one technique may not be more effective than another, but it is to say that the most efficient file design is the best file to use, whatever the technique. It was the comprehensive analysis of this previously unavailable research that compelled us to design the One Endo File, to form Nano Endo, and to advance expertise for endodontic instrumentation.